Here we're looking at topic 65, example 2, where we graph a piecewise defined function. So how do you graph a piecewise defined function? That's our question. And they give us the function f of x, where there's three parts. We have 4x plus 11, x squared minus 1, and x plus 1 with their respective domains. So they want us to graph it. Then they're also asking for the domain and range, and what intervals is the function increasing or decreasing. So first part of graphing it, let's start with the 4x plus 11. There's a couple different methods. Sometimes you can look at y-intercepts. Sometimes you can just look at the graph and know where it's going to be. But one of the clearest methods is taking values and plugging them in to find 2 points. What I generally recommend is, in this case of 4x plus 11, I would recommend plugging in your limitations, right, the minimum and maximum of your domains, and that'll give you your 2 endpoints. There is a note to that I'll point out in a second, but for the most part, you can go with that. So I'm going to take negative 10, and I'm going to say 4 times negative 10 plus 11, and figure out what that would be. So 4 times negative 10 would be negative 40, plus 11 would be negative 29. So that gives me the point negative 10, negative 29. So I'll plot that. Negative 10, negative 29. It's equal to it, so I'm going to put a closed circle at negative 10, negative 29. And then I'm going to do the same thing using the max value for that specific domain, in this case, negative 2. So I'd say 4 times negative 2 plus 11. That would be negative 8 plus 11, which equals 3. So that gives me the point negative 2, 3. So negative 2, 3 would be here. Again, this time, or not again, this time, notice that here it's just less than. It is not equal. So this one is going to be an open circle there. And then what I can do from there is I can connect these two dots because it's a linear function. Okay. So not too bad, pretty straightforward. And you want to do the same thing for the next two parts of your piecewise defined function. So again, what you're doing, I'm going to write the next one in red. We have x squared minus 1. You're taking your values, your minimum and your maximum of your domains for that specific function. So here I would do x, sorry about that. I would say negative 2 squared minus 1. So that would be 4 minus 1, and that would be equal to 3. So we have the point negative 2, 3. It's going to be a closed circle there. So we want to be right at that negative 2, 3, and I'm going to put this closed circle here just to kind of fill in, what happened before. We're going to use different colors for this. But depending on what part you're at, this negative 2, if you have a negative 2 for the domain, right, you would be using this second part of your piecewise defined function. And then this goes up to positive 2. So we would then do positive 2 squared. So that would be, again, 4 minus 1. That would be 3. So we have the point 2, 3. Let me just highlight one more piece here. Should have highlighted this before. Sorry about that. So now we have 2, 3. This one is a closed circle again, so that's going to go right there. Now, what we have to be careful of, and this is one of the exceptions, notice that this is squared, so we can't just connect these two dots. All right, it's not a linear function. So we would need to figure out, it's squared would be a parabola. We would need to know a little bit about parabolas and terms to figure out the rest of the graph. You could graph this on a graphing calculator. You could plug in another number. I would recommend 0, so you could find another point in the middle of your graph. So let's do that. So I'm going to say 0 squared minus 1, and this is going to give me the shape of my parabola. So that would be 0 minus 1, negative 1. So we have the point 0, negative 1. And if you know some stuff about parabolas, then you'll realize that that is the vertex. All right, so we have a shift of minus 1. Remember, that's a k value from the last section, so it's going to shift down one spot. So we're just going to draw that there. Let me actually make this line a little bit more pronounced. Okay. All right, and then finally, we're going to do our third part of our graph, and we'll do that one in green. It's a linear function. The linear ones are easier because we don't have to worry about any curves. So we have x plus 1, and we're going to use 2 and 10. So I would say 2 plus 1, that's pretty easy, it's just 3. So I have the point 2, 3. And I have the point where 10 plus 1 would be 11. So we'd have the point 10, 11. All right, so 2, 3 would be here. That's going to be an open circle. So we can just kind of put that open circle there. But at 2, we would be concerned with the second part of our piecewise defined function. And the second point is 10, 11. That's a closed circle because it's equal. And we'll put that point right there. And then we can connect these 2 points. So the open green circle would be there. We don't really need it in this case, kind of like we didn't need that open blue circle that was right there, because those are taken care of by the red portion of our graph. So that's how we graph the piecewise defined function. So we've graphed it. Now we need to figure out what the domain and range are, and over what intervals is the function increasing or decreasing. So again, to actually graph it, you would plug in your minimum and maximum, and those will give you kind of think of them as like endpoints for your graph. Just be careful if you have a linear functions, are easy. Be careful if you have a quadratic or a cubic, anything with any type of curves or a vertex. So do be careful with that. So let's talk about the domain and range. The domain, we're looking for our minimum and maximum, right? So there's going to be the smallest number we have, which in this case, if we're looking left, is at negative 10. And then a largest number, which in this case would be 10. There's no breaks in our graph, right? Every number is accounted for. The blue portion, there was an open circle at negative 2, but that's taken care of by the red portion of our graph. So there's no breaks in our graph. We have a minimum of negative 10, inclusive, right, because it's closed circle, and then that goes up to a maximum of 10. Okay, remember, domain, you're looking left and right. In terms of range, now our range, again, we're going to look for a minimum and a maximum value. Well, the lowest point for my range is right here, and the highest point for my range is right here. The lowest value was negative 29, right? We found that using the 4x plus 11, and the highest value would be 11. And that was found using the green one or the x plus 1. So domain and range usually aren't too bad. Sometimes there are breaks in your graph, so you'll have different portions. You know, if a certain part didn't exist, you would have 2 pieces to your domain, or 2 pieces or 3 pieces to your range, however it worked out. All right, and then finally we want to look at, so we covered domain, we covered range. We want to look at when the function is increasing and when it is decreasing. Okay, so increasing, let's look at that first. Remember, increasing is when we're looking left to right, and since it's an interval, we care about x values. So this graph is going to be increasing from the start. It's going to keep going up until we get to this point here. So if I'm looking at x values, that increases from negative 10 to negative 2. So it's increasing from negative 10, wrong marker. It's increasing from negative 10 to negative 2. Remember to use parentheses because at negative 10, it's not actually increasing. That's right where it starts. And then it stops increasing at negative 2. But we also have another part of the graph that increases. And that's going to happen right here. It's going to increase along this curve here. It's going to increase along this curve here and then continue for the rest of our graph. So that increase happens again. My marker is not cooperating. So from negative 10 to negative 2 and from 0 to 10. So there's 2 portions. Let me clean that up. there's two portions where it's increasing, or two, having some trouble writing today. So from 0 to 10, it's going to increase. There's two portions, that leftmost portion, and then half of the red one on the right, and then the entire green part of our graph. Now we also need decreasing, right? So let's figure out where our graph is decreasing. Well, it was increasing in the parts that we highlighted in blue. From here to here, there's just going to be a small piece where it decreases, and that's going to decrease from -2 to 0. Remember, we are looking for x values because we're talking in terms of intervals. So we figured out when it's increasing, we wrote when it's decreasing, and we've answered all the questions. So one last time, quick run through. The first thing you do to graph them, you usually want to find the endpoints. Works very well for linear parts or linear pieces of a piecewise defined function. Do be careful, I can't stress enough, when you have something like a quadratic, be careful, don't connect the two endpoints with a straight line. That would be a curve, we need to use a parabola here. Okay, so do be careful with something like that. But generally, the best approach you can do is take the limits for your domain, the minimum, maximum, and plug those in as we did in these three pieces here. And then domain, range, and increasing, decreasing, you should be pretty familiar with. So I think you'll be okay with that.